Hey, let's look at Trig Unit Test Review Worksheet number 2. First two problems, we're just going to look to solve these trig equations. Rather than getting this out of double angle form, we're just going to, I'm just going to go through inverse trig to solve. So first thing, I'm going to apply inverse cosine to the other side. So 2x equals inverse cosine of 1. You want to figure out when is cosine equal to 1. Okay. Cosine is equal to 1 at intervals from 0, 2 pi, 4 pi, 6 pi, 8 pi. The reason why we're going more than the actual domain is because eventually we have to solve for x. When we solve for x, that means dividing by 2. So that means these values all have to be divided by 2, and that's what we're going to be comparing with our domain. So I'm going to go way over just to make sure that after I divide by 2, I have everything covered. So 0, 2 pi, 4 pi, 6 pi, 8 pi. Okay, next step, solve for x. Divide every term, every solution I have by 2. So 0 over 2, 2 over 2, 4 over 2, 6 over 2, 8 over 2. And this comes out to be 0, pi, 2 pi, and 3 pi. From here, we're looking for a solution that's between 0 and 2 pi, and then out of all of our choices, we can now narrow down to just pi. Okay. Okay, let's look at number 2. Solve for x, tangent of 4x equals 1. So apply inverse tangent. So we want to figure out first, when is tangent equal to 1? Okay, notice we have to divide by 4 eventually, so I'm going to list out a whole bunch of terms. Pi over 4, 5 pi over 4, so everything in the first and third quadrant. Right? So pi over 4, if I add 2 pi to this, I'll get 9 pi over 4. If I add another 2 pi to this, I'll get 17 pi over 4. And third quadrant, 5 pi over 4, if I add 2 pi to this, I'll get 13 pi over 4. Alright, and so now we divide all of our values by 4 because we're trying to solve for x. So now we have pi over 16, 5 pi over 16, 9 pi over 16, 13 pi over 16, 17 pi over 16. Now all these values are between 0 and pi, right? 13 pi over 16 is smaller than pi. 17 pi over 6, we know that's out. So we know our solution will only be 4. So I think it's always a good idea to list out more than you need, just so that you can convince yourself that that you've covered the last one. Because the next one, 17 pi over 6 is out, so we know all these are, they must be all of our solutions. Okay. Alright, number 3, find the critical points for our function e to the x plus sine of 2x in the domain between 0 and 2 pi. Right, if we want to find critical points, we have to set our derivative equal to 0. So to find our derivative, notice that this is in the form of e to the u, and the derivative for e to the u is e to the u times u prime. So e to the u times u prime, so x becomes 1. Sine of 2x becomes cosine of 2x times 2, right? So sine of 2x, this is a chain rule. Sine of u becomes cosine of u times u prime. Okay. Now we're going to set both parts equal to 0. E to the x plus sine of 2x is never equal to 0, right? If we try to take natural log of both sides, natural log of 0 is undefined, so we know this value will never be equal to 0. So we look at this other parentheses, 1 plus 2 cosine of 2x equal to 0. Okay. Subtract 1, divide by 2. Take the inverse of cosine of both sides, or arc cosine of both sides. And inverse of it should be 2x equals inverse cosine. Right, inverse cosine of negative 1/2. Okay. So cosine is equal to negative 1/2 at 2 pi over 3. 4 pi over 3, 8 pi over 3, 10 pi over 3, 14 pi over 3. And then divide every term by 2, and I'm going to get pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay. Or we could take the cosine 2x, apply the get it out of the double angle by applying 2 cosine squared x minus 1. If we go through this procedure, we would also get to the same solutions. So cosine x equals to plus or minus 1/2 in the first, second, third, and fourth quadrants. Okay, number 4, find the equation of the tangent line to the graph at 3, -1 for the equation sine of pi x plus cosine pi y is equal to x squared times y. So we first need to find the derivative of our equation here. This is sine of u, this is cosine of u, but here x squared y, we have to apply product rule. So notice all the rules that we have to apply for defining the derivative. There's implicit differentiation involved here because there's y's mixed in. There's chain rule, there's trig rule, there's product rule as well. Okay, so one step at a time, we're going to go through our derivative rule. Sine of u becomes cosine of u times u prime. The derivative of pi x is simply pi. The derivative of cosine of u is negative sine of u times u prime. The derivative of pi y is pi times 1, but then we are involving y's derivative, so we have to attach dy dx. Okay, x squared y, product rule, f prime g plus f g prime, so 2xy plus x squared times the derivative of y, which is dy dx. Okay, now one step at a time, we're going to solve for dy dx. And rather than trying to get dy dx by itself, all we need to find is the slope. So we can just go ahead and plug 3, -1 for the x and y's and solve for dy dx. Alright. So every x I see I'm going to replace with 3. Every y I see I'm going to replace with a -1. Okay, so I get pi cosine 3 pi minus pi sine negative pi dy dx equals 2 times 3 times -1 plus 3 squared times dy dx. Cosine of 3 pi is simply -1. Sine of negative pi is simply 0, so that's going to cross out all these terms. -6 on the right side plus 9 dy dx. So negative pi is equal to -6 plus 9 dy. Now we can solve for dy dx a lot easier. Just move everything over to the other side. So add 6, divide by 9. So dy dx, our slope, is negative pi plus 6 over 9. We have our slope, we have our point, and now we just plug into our point slope. Okay, y minus y sub 1 equals m times x minus x sub 1.